All right, so we had just finished talking about the translation properties. After that, we had gone on to do powers and derivatives. So this property L of t to the n f of t equal to minus 1 to the nth derivative of f with respect to s, that one you just use when t to the n appears in your ODE. It's one of those really straightforward ones. The inverse property is really tricky. That one's hard to identify when to use it. And the only tip I would have for being able to use it is just to remember a couple functions where this is a property that helps you out. So like the one we did in lecture was that if you have something like s over s squared plus k squared squared, that comes from taking the derivative of 1 over s squared plus k squared. This must be having an extra k term like that. So just if you remember the cases where you can use the derivative property, it can save you a little bit of time. But if you can't remember them, we showed later on in that video that you usually can just compute the inverse Laplace transform a different way. So after that, we moved on to the convolution and product properties. So kind of a pattern here is the forward direction is a little bit less useful to us. You have to have a convolution that you want to take the Laplace transform of. That seldom happens. So I would say you don't have to worry about using that one a lot. But this L inverse of f times g is equal to the convolution of little f and little g. This one is useful a lot. So a lot of the time when you solve for capital Y, you do end up with products of things. And then when you're taking your L inverse, this becomes useful because you don't have to worry about decomposing them or handling them in some other way. The stars I wrote right here are for warnings about this thing. And just remember that convolution order doesn't matter. And so you can go ahead and pick f versus g in the easiest possible way. Remembering that t minus tau is an important part of this that you have to deal with. And then just now in this set of videos, we learned about the delta function. Use it when it appears. And then we talked about how you undo the delta function when we talked about our step function. So no problems there. And then we talked about the periodic function, which that's just sort of another type of definition that we can work with. And the only tip I would have there is just that the challenge is from finding out what the period t is and then taking a piecewise integral. For the example we did, or just sort of taking the little piece that you do need for that integral and only integrating over that part. So those I think are all the tips and recaps I have about Laplace transforms. I'm going to stop here. Our last video is our wrap up for this set of videos.